Hello students, welcome to Uncle Matt's Online Academy. Today we'll be talking about measurements. In the course outline, we have measurement, speed, velocity and acceleration, graph of equation, falling bodies and density. Let's move to the next slide. Here, measurements and motion. Can you imagine what the world would be like without the knowledge of measurements? Can take a moment and think of that. How would our communications be understood? This next conversation will throw more light on the question being asked. There are two friends. Mr. A, who is the first friend, told Mr. B, his friend, that he has 3 to spend here and he still has 50 to cover to get home. His friend Mr. B was amazed and asked, 3 what and 50 what? Mr. A smiled and said, I was just joking around, friend. I mean 3 minutes and 50 kilometers. Oh, exclaimed Mr. B. Now I understand. I've got to release you now. From this conversation, initially Mr. B didn't understand his friend Mr. A. Why? We'll get to know in the next slide. So, let's continue. Measurement is in 2 parts. For a measurement to be understood, it has to be in 2 parts. The first part is the magnitude, and magnitude means size. When you say size, how big something is, whether it is large or it is small. The other part of measurement is the unit. I have an example for you here. We have 100 meter. 100 meter. The 100 is the magnitude. When you hear 100, that thing must be big. It's different from 1, it's different from 2. Then we have the meter. The meter tells us the physical quantity that is being measured. When you see meter, then you know it is talking about length or distance. There's no way you see meter and you think it's time that the person is talking about. So can you see when you have 100 meter, then you understand what the person is saying. So back to the former conversation. The reason why Mr. B didn't understand his friend was that he didn't make use of proper measurements. He only gave us the magnitude without telling us the unit. But by the time he added the units, his friend understood him better. Let's proceed. We have some physical quantities and their basic units. So some of those quantities are those ones that we work with from day to day. We have our length, and the unit for length is meter. The unit for length is meter. We have our time. When you talk, the basic unit for time is second. We can have other units like our hour. We can have hour. Then for mass, the basic unit for mass is kilogram. The basic unit for temperature is Kelvin. We have other units, but the basic one is Kelvin. We can have our Celsius. We can have our Fahrenheit. For electric current, the basic unit is ampere. For the amount of substance, the basic unit is mole. Let's proceed. This next slide shows us some instruments that are used for measurements. From the image, we can see our tape rule, we can see our measuring tape, we can see our ruler. These ones are the instruments used for measuring length. Other instruments that we can have the clock. The clock is used to measure time. Our stopwatch is used to measure time also. Hourglass, in the olden days, they used hourglass to measure time. It's a glass that has been filled with sand. So the sand drops according to a known period. We can have our ruler, as we mentioned earlier. We can have our weighing scale or balance. The weighing scale or balance is used to measure our mass. We can have our ammeter. Ammeter is simply used to measure electric current. We can have our thermometer. Can you guess what the thermometer is used to measure? Our thermometer is used to measure temperature. Let's proceed to the next slide. Now, we've talked about measurements. Let's now talk about motion. What is motion? Motion refers to the phenomenon in which an object changes position with respect to time. It is simply the act of changing the position of the body. Why do you have to change the position of your body? Probably the body was at a rest position. So rest is the opposite of motion. Rest is a state in which the body is not moving. It's just stationary. So you might just want to change the position of the body. So by the time you change the position of such body, the body is already in motion. So motion is mathematically described in terms of some physical quantities such as displacement, distance, velocity, acceleration, speed, and time. These are some of the physical quantities that describes motion. Let's move on to the types of motion that we can have. There are various types of motion. There are different ways in which you can move your body to change the position, but these are the common ones we want to speak about. The first is the rectilinear motion. Rectilinear from the word recti and linear. When you see the linear is like a straight path. So let's define rectilinear motion. Rectilinear motion is defined as a motion on a straight line or a path. If you want to practice the rectilinear motion, you can draw your straight line that is not curved, your straight line, and try to walk along that line. If you practice that, your body will be said to be undergoing a rectilinear motion. If you have a straight road, which is very straight, and a car moves along that straight narrow road, the car will be said to be undergoing rectilinear motion. Now, we'll move on to circular motion. As the name implies, circular, you know our shape, you know the shape of the circle. Yeah. When you have a circle drawn and you move around the circular parts, like the edges of that circle, your body is said to be undergoing a circular motion. Or for example, we can have a circular track. Probably it's a sport and they draw a circular track that, okay, cars should move around that circle. So the motion of a car around that circular track will be said to be a circular motion. Let's move to the next type of motion, which is the Brownian motion. Is this sounding strange? No, don't let it be. The Brownian motion is a very simple type of motion because it is a movement in an irregular pattern. That is, you just move anyhow, just as your brain tells you to do. You can decide to go right, go left. Some people say an haphazard way of moving. Yeah, that is it. It is known as a random motion. For example, when you just see an insect moving anyhow, no clearly defined parts, the insect will be said to be undergoing a Brownian motion. The fourth type of motion we are going to talk about is the periodic motion. And what is a periodic motion? Periodic motion is the motion of the body about a fixed position. It is also known as a to and fro movement. When you move about a particular position with time, an example is the movement of a pendulum bob. or the movement of a swing. That's a very common example. The swing will just be going up, like to the front, to the back, to the front, to the back, but the swing is fixed at that position, so you are still fixed at a position. Let's move on to the next type of motion. The next type of motion here is the rotational motion. You can emphasize what rotation is. It's like a circular motion too, but there is a fixed axis here. Rotational motion is defined as the spinning movement of a body about its axis. That's the simple definition for rotational motion. It can be seen in the rotation of the earth about its axis. It can also be seen in the rotation of the wheel about an axle. Now that is that on the types of motion. Let's move to some of the physical quantities that can be used to describe motion. The first physical quantity here that can be used to describe motion is our speed. I'm sure you are familiar with what speed is. Sometimes someone wants to call you and be like, please come with speed, come running in speed. Probably the person needs your attention. You understand? When say speed, like do fast, things like that. That's a layman's language for that by the side. So let's go back to our notes. What is speed? Speed is defined as the rate of change of distance. The rate of change of distance. Or you say the distance traveled per unit time. Or you say what? The distance traveled per unit time. So speed tells us how fast a body is moving. It tells us how fast a body is moving. So speed can be expressed mathematically as distance over time. So when you work it as distance over time, you should be able to state what the units would be. Since distance is in meter and time is in second. So at the end, we have the unit for speed to be meters per second. Let's go on to the next physical quantity that can be used to describe motion. The next physical quantity that can be used to describe motion here is velocity. What is velocity? Velocity is just like speed. The only difference is that our velocity is a directional speed. That means in terms of velocity, you have a particular direction. So, let's continue. Our velocity can be defined as the rate of change of displacement, or we say it is displacement per unit time. That is saying displacement divided by time. Also from here we can calculate our units for velocity. So we'll be having meter divided by second, that is displacement divided by second. So at the end we have the unit for velocity to be meters per second. Can we see that it's similar to speed? Yeah, that's what I'm talking about. Let's go to the next slide. Here we have acceleration. How many syllables is in that? Acceleration is defined as the rate of change of velocity. It is defined as the rate of change of velocity. A body is said to accelerate when its velocity changes. A body is said to accelerate when its velocity changes. If our velocity is here and our time is here. A body that was initially at 0, by the time it changes its velocity, we say the body is accelerating. Oh, pardon my pen. We'll have a better illustration in the next video. So thank you for watching. We'll continue in the next class. Bye.